and welcome to Encouraging Engineering. Today, I'm going to teach you the fundamentals of Arduino, including what it is and how we use it. Encouraging Engineering is a project created to encourage anyone to pursue engineering and STEM. While there's limited videos on this account, we hope that teaching you some fundamentals, projects, and useful tips will encourage you to pursue more on your own, and potentially in a career. No matter the reason you're here, I hope these instructions will show you how fun the world of engineering in Arduino is. One more important note, if you're a more visual or solo learner, we have these slides linked in the description for you to use. You can even follow along with the video. Also, if something doesn't make sense in this video, the slides and description below contain some links to other websites that can give you additional help. Now, onto the fundamentals of Arduino. Before we start, it's important to understand what Arduino is. Arduino is an open source platform with its own programming language and IDE, also known as an integrated development environment. You'll learn how to use it throughout these lessons. To program your circuits, your Arduino board will serve as the brains, allowing you to control components like sensors and motors. There's a variety of Arduino boards available, each with different sizes and uses. Over these lessons, we'll be focusing on the Arduino Uno board. This is a simple and popular board among users, so it's perfect to start with. To connect your components and create a circuit, you'll need an Arduino breadboard. These look a little complicated, but as long as you understand how electricity flows through it, it should be simple. Two of the same boards as an example. The left and right sides have these long sections with positive and negative symbols. Generally, you'll connect your Arduino's power source to the positive side and then ground to the negative side. We'll explore these concepts more in the next lesson. Here in the middle section is where you'll connect the components with each other, the power and the ground. This is where you need to understand how electricity flows through the board. Looking at the back, you'll see metal bars placed horizontally across both sides of the middle. When you connect your power to one line, it won't connect to the others unless you cross over with other components. Make sure you know how the breadboard works before making your own circuits. Now that you understand the Arduino Uno and its breadboard, let's move on to the most important concept when using electronics: how to use it safely. Working with circuits may seem dangerous, but using Arduino is generally safe if you know what to do. However, there are some tips and practices you should use to avoid small injuries or problems. The first and most basic rule of thumb is to keep food and drinks away from your circuit. Crumbs and liquids could end up in the breadboard or Arduino holes, preventing the circuit from working correctly. Worst case scenario, you won't be able to fix the damage and you'll have to buy new components. Make sure to keep your project somewhere safe. Rule 2 is to avoid removing components while your circuit is powered. For instance, say you're powering an LED and decide you want to rearrange how the circuit is set up. Do not remove the components until you unplug the Arduino. Doing so could lead to you either shocking yourself or, if the circuit is left broken too long, result in a buildup of power that could lead to a fire. Again, Arduino is generally safe and rarely catches fire, but part of that safety depends on being able to identify if something is wrong, which leads us to Rule 3. Unplug your components if they feel too hot. When powering your project, none of your components, including the Arduino board and breadboard, should feel hot to touch. It should feel cold or slightly warm. If you're powering your circuit and notice something is rapidly heating up, immediately unplug your project and recheck your circuit. You may be missing a component or have set up the circuit incorrectly. Do not plug your Arduino again until you've identified and fixed the issue. Failing to unplug the circuit could result in your Arduino smoking and eventually catching fire, so make sure to keep an eye out for any temperature issues. Now that we understand some basic safety, let's set up the Arduino IDE on your computer. If you're using a school computer or another device that prevents downloads, skip to here for an alternative way to use Arduino. Otherwise, follow the instructions here to download the Arduino IDE. First, go to the Arduino IDE link in the description or copy the link on screen. It should load a page like this with several file links. You should pick the file that corresponds to the type of device you're using. Also, don't worry about the version number here. If you're watching this video in the future, it's likely that you'll see a different version. Either way, the setup process should be the same. Once it stops downloading, open the download and follow the instructions shown on screen. After some loading, an Arduino icon should appear on the desktop screen. Click it, and you will have access to the Arduino IDE. This is where you'll be typing the code for your projects. We'll explore it in more detail as we go through these lessons, but for now everything should be set up. Unfortunately, if you're using a school laptop, you won't be able to download the IDE due to restrictions on your device. However, you can still use Arduino and build your own circuits by using online simulators. There are hundreds available on the internet, but I'd recommend either Tinkercad or Walkwe. Tinkercad is good for beginners, and Walkwe is better for intermediate users, but both should work fine if you want to follow these lessons. Both websites will be linked in the Unfortunately, if you're using a school laptop, you won't be able to download the IDE due to restrictions on your device. However, you can still use Arduino and build your own circuits by using online simulators. There are hundreds available on the internet, but I'd recommend either Tinkercad or Walkwe. Tinkercad is good for beginners, and Walkwe is better for intermediate users, but both should work fine if you want to follow these lessons. Both websites will be linked in the description below. Before we end, I hope this video was useful and taught you something new. Arduino might seem complicated at first, but it's a lot easier as you understand more. Good luck in your future projects, and thank you for watching.